students, today class we are going to see preparation of ethers. Okay, ethers, the functional group is O. Okay, so there are two kinds of ethers, symmetrical ether and mixed ether or unsymmetrical ether. Okay, so methoxymethane, this is a symmetrical ether. Ethoxymethane, this is unsymmetrical ethers. Okay, so here we are going to see the preparation of ethers from alcohol. Okay, so from alcohol, that is dehydration of alcohol. Dehydration means the removal of water molecule. Okay, right. Here the alcohol, it undergoes dehydration reactions in the presence of protic acid like corn sulfuric acid. Okay, the conditions alone it different. Okay, for 413 Kelvin low temperature it produce ether. At the same time the higher temperature 443 Kelvin it produce ethane. Okay, so this method, dehydration method, only for primary alkyl group. Okay, not suitable for the secondary and tertiary group. Okay, because of the secondary here, listen here. So this alcohol in the presence of corn sulfuric acid at lower temperature 413 Kelvin it produce ether. Okay, plus H2O because of dehydration reactions. Let me take an example for another one, ethanol. Okay, or ethanol. Okay, so in the presence of corn sulfuric acid, this is what ethoxyethane plus H2O. Okay, suppose methanol means in the presence of corn sulfuric acid, methoxymethane. These all the all are symmetrical ethers because of the same kind of alkyl groups are present. Okay, right. At the same time, the same alcohol in presence of corn sulfuric acid, the temperature would be high, 443 Kelvin. So we can get ethene. Alkene is a product. Okay, so these reactions, what are the limitations we observed? The limitation number one, that is a dehydration of secondary and tertiary alcohols may give an alkene due to beta elimination. Okay, already we studied even at lower temperature, therefore dehydration of secondary and tertiary alcohol is not suitable method for preparation of the ether. Okay, so the secondary and tertiary alcohol, it is not suitable because of it undergoes the removal of OH from alpha carbon atom and removal of the hydrogen from beta carbon atom. This is one beta carbon atom, this also beta carbon atom. We can remove, finally it gets H2O. Okay, dehydration H2O. We can get this bond is shifted to here, that is double bond, it attains double bond, so alkene. Okay, so that is this method is not suitable for the preparation of ethers. Okay, only the method cannot be used for the preparation of unsymmetrical ether or mixed ether, and also this method cannot be used for the unsymmetrical ether as well as the mixed. Unsymmetrical ether is nothing but mixed ether. Okay, next preparation is Williamson synthesis. Okay, so earlier we studied dehydration of alcohols. Dehydration means removal of water. So there we studied the reaction conditions vary. It produced ether and alkene. Okay, so here, and also the secondary and tertiary form is not suitable for the hydration method, alcohol dehydration method. Okay, so here the next one is Williamson synthesis. Okay, Williamson synthesis, first of all the alcohol is reactive with the reactive metal is sodium. Okay, sodium alkoxide is produced. Okay, so that sodium alkoxide is reactive with alkyl halide. Okay, it produce ether and NaX. Okay, so the condition is for Williamson synthesis is suitable for both symmetrical as well as unsymmetrical ethers. Okay, so here suppose the alkyl halide, it must be in primary form, because here the alkoxide in the presence of sodium alkoxide, it may be secondary or tertiary, the sodium primary, the sodium alkoxide, it acts as a nucleophile as well as the base. Okay, so it undergoes nucleophilic substitution reactions. Here, why it is the condition for this case for primary alkyl halide, because of the SN2 reactions takes place. For SN2, the order of reactivity is primary, after stability secondary, after that tertiary. Okay, students, you keep it in that the alkyl halide must be in primary form, otherwise we cannot get the yield. நம்ம primary formல இருந்தால் மட்டும்தான் நமக்கு expected product வந்து கிடைக்கும், நிறைய excess of yield கிடைக்கும். இல்லை அப்படின்னா we cannot get the yield. Okay, so here also this is nucleophile, so this go and attack this carbon atom. This is a leaving group, so it leaves and the sodium and bromine, it undergoes sodium bromide, so we can get the ether. Okay, substituted ether. Okay, so and suppose the third condition, the primary alkyl halide, it is a expected product. The tertiary alkyl halide, so the react with alkoxide, we cannot get the ether product. So alternatively we can get alkene. Why? Because of here this is a leaving group, this beta eliminations takes place, so it undergoes beta eliminations, it produce the alkene is a product. Okay, so அப்போ primary alkyl halide இருந்தால் மட்டும்தான் நமக்கு ether product கிடைக்கும். tertiary alkyl halide இருந்துச்சு அப்படின்னா we cannot get the ether product, alternatively we can get the alkene. Okay, so this is a, and haloarenes also do not prepare the ether. Okay, so we cannot prepare from haloarenes also, because of haloarenes it does not undergo nucleophilic substitution reactions. Okay, these are the conditions, you keep it in that in your mind. So this alkyl halide must be in primary form, because of the SN2 reactions takes place. The SN2 reactions, the order of reactivity is primary, secondary, after tertiary. Okay, so the tertiary halide means it produce alkene. Okay, right. So next one is chemical reactions, cleavage of CO bond in ethers. Students, this is very important reaction mechanisms. Reaction with hydrogen iodide for symmetrical ether. Okay, symmetric ether means these two R groups are same. Okay, methoxymethane, it react with hydrogen iodide in presence of cold conditions. It produce two products, that is alkyl iodide and alcohol. Okay, alkyl iodide and the alcohol. At the same time, the same symmetric ether, the excess of hydrogen iodide, it is a hot condition, heating. Okay, so heating, it produce alkyl iodide plus H2O. Okay, students, so the normal, the symmetric ether உனக்கு எக்ஸாமில் கொடுப்பாங்க, கோல்டா ஹீட்டா ஹாட் கண்டிஷனா அப்படின்னு பார்க்கணும். ஸோ ஹாட் கண்டிஷன் அப்படின்னா the product must be, your product must be only alkyl halide with water. Okay, so it is in the cold form, there is a alkyl halide plus alcohol. Okay, so this also you keep it in that in your mind. Then next, the same, suppose the ether would be in unsymmetric conditions. Unsymmetric means this R group is methyl group, this R group is ethyl group. Okay, so methoxyethane or ethoxy, alpha, according to alphabetical order, E comes first, ethoxymethane. Okay, this is the IUPAC, you know. So this react with hydrogen iodide, it produce, இங்கே நல்ல கவனி, எப்போவுமே இந்த மாதிரி இருந்தது அன்சிமெட்ரிக் ஈத்தரில் இருந்தது அப்படின்னா இந்த அயோடின் வந்து என்னது, இட் கோ அண்ட் அட்டாக் வித் த லெஸ்ஸர் நம்பர் ஆஃப் ஹைட்ரஜன், த ஹைட்ரஜன் கண்டெய்னிங் லெஸ்ஸர் நம்பர் ஆஃப் கார்பன் ஆட்டம், அல்லது என்னது த ஸ்மாலர் alkyl group. This iodine go and form the smaller alkyl group. Okay, so this is the hydrogen goes to form the larger alkyl group. அப்போ நமக்கு என்ன கிடைக்குது, so this iodine CH3I alkyl iodide plus CH3CH2OH. ஓகே, நல்லா ஞாபகம் வச்சுக்கோங்க. அன்சிமெட்ரிக் கண்டிஷனில் ஹைட்ரஜன் அயோடைடு இருந்தது அப்படின்னா இந்த அயோடின் வந்து எங்கே போகும் அப்படின்னா லெஸ்ஸர் அல்கைல் இந்த ஸ்மாலர் அல்கைல் குரூப்பில் போய் ஆட் ஆகும். இந்த ஹைட்ரஜன் வந்து லார்ஜர் அல்கைல் குரூப்பில் போய் என்ன செய்யும், ஆட் ஆகும். சரியா? ஸோ திஸ் இஸ் யுவர் ப்ராடக்ட். Iodide as well, alkyl iodide as well as the alcohol. Okay, so in case this is a tertiary group, okay, so tertiary group with hydrogen iodide, the product that is a tertiary alkyl halide. Okay, எப்போவுமே டெர்ஷரி குரூப்போட ஹைட்ரஜன் அயோடைடு இருந்தது அப்படின்னோன்னா நமக்கு என்ன தான் கிடைக்கும், டெர்ஷரி அல்கைல் ஹாலைடு தான் கிடைக்கும். பிகாஸ் ஆஃப் இட் அண்டர்கோஸ் this is SN1 mechanism. For SN1, what is the order of reactivity? That is 3 degree and 2 degree and 1 degree. For first it produce this hydrogen iodide react பண்ணும்போது first வந்து slow stepல என்னதாகும், இதான் லீவிங் குரூப் CH3O அப்படிங்கிறது வந்து ஹைச்சோட சேர்ந்து லீவிங் குரூப்பாக இருக்கும். இது வந்து கார்போகேட்டைனை ஃபார்ம் பண்ணும். கார்போகேட்டைன் இஸ் அ ஸ்ட்ராங்கஸ்ட் ஒன். ஓகே, அதுக்கப்புறம் இந்த அயோடின் வந்து கார்போகேட்டைனை நான் அட்டாக் பண்ணுறப்ப நமக்கு என்ன கிடைக்குது, இதில் வந்து டெர்ஷரி அல்கைல் அயோடைட் அண்ட் this leaving group CH3OH. Okay, so after that this is for symmetric, this is for unsymmetric. Suppose this is a aromatic form. Okay, aryl form with OCH3, aromatic ether. Okay, this is what, anisole. Okay, methoxy benzene or methoxy. So this is aromatic ring attached with this methoxy group ether. Okay, aromatic ether. So this react with hydrogen iodide. This here the bond cleavage takes place here. இந்த OCH3 cleave ஆகிறதுனால இந்த ஹைட்ரஜன் வந்து இங்கே ஆட் ஆகுது. இந்த CH3 வந்து CH3 alkyl iodide போயிருது. ஏன் அப்படின்னோன்னா this is a stronger. Here you see that this bond cleaved because of this O, it contains a lone pair of electrons. It ready to donate the lone pair of electron to this carbon atom here to create a partial double bond. After creating the partial double bond, it undergoes pi bond delocalization resonatic structure. Okay, so this C double bond O, it is a stronger bond. Okay, we cannot break easily. Okay, so this is a condition. So this OC, this bond cleaved and this iodine go on attack, we can get the phenol is the product and CH3I is another. So this is not your product. இப்படி product எழுதுனா அப்படின்னா இது தப்பு. சரியா? So because of this is a stronger bond, this is stronger bond. Okay, so this all you must keep it in that in your mind, very very important. For symmetric it is a 2 product. For unsymmetric with hydrogen iodide, in the iodine வந்து this is a alkyl group, smaller alkyl group. This hydrogen for larger alkyl group. There are 2 products. Tertiary group இருந்தாலே we can get the tertiary alkyl iodide because of SN1 mechanisms takes place. இங்கே இது வந்து it is a stronger bond. Okay, almost we covered all the topics. This is the last one, electrophilic substitution reactions for ethers. Okay, so here the alkoxide group. Okay, this alkoxy group is orthopara directing and activates the aromatic ring towards electrophilic substitution reactions. Okay, like a phenol. Okay, here you see that this lone pair of electrons donate here to create the partial double bond and pi bond shifting takes place. Ortho position, it's the electron density is more, then pi bond shifting takes place. Para position is electron density is more, then so like that the pi bond shifting takes place. Okay, due to the resonance. Okay, plus or effect. Okay, right. So halogenation, here you see here that 15. Okay, minus charge. Okay, right. Okay, halogenation reactions. Halogenation reactions means normal haloarenes we studied. Normal halogenation reactions takes place in presence of catalyst like iron bromide or aluminum chloride. It acts as a Lewis acid. But here that halogenation, direct halogenation reactions takes place because of this presence of alkoxide. Okay, so that is the phenyl ethers undergoes halogenation reactions. Okay, this is alkoxide, this present. So this alkyl group with this oxygen donate the pair of electron to shifting here, the pi bond delocalization takes place to the incoming groups to the directed to the ortho position as well as the para position. Okay, um, this is anisole. Okay, react in the presence of bromine in ethanoic acid, that is para bromo anisole. Okay, here bromine comes, para bromo anisole, and here ortho bromo anisole. Compared to this, para position is a major. Okay, presence of this OCH3 group activate the benzene ring. The incoming electrophile bromine, the incoming electrophile go and attack the electron rich positions where the electron rich present ortho as well as the para. Okay, because of resonance. Okay, right. Friedel-Crafts reactions. Friedel-Crafts reactions, it takes place, already we studied here, that is alkyl chloride and acyl chloride. Okay, so here anisole react with alkyl chloride in presence of anhydrous AlCl3 CS2. This is a AlCl3 Lewis acid. Okay, so this Lewis acid in presence of CS2. Okay, so this here the CH3, this is a leaving group. CH3 plus is the electrophile. Okay, so this electrophile go and attack the ortho position and para position. Okay, so we can get 2-methoxytoluene and 4 1 2 3 4 4-methoxytoluene. Compared to this, para is a major. Okay, so the same thing acyl reactions, acyl chloride. Okay, so this CH3CO plus is a electrophile. So this electrophile attack ortho position as well as the para position. Okay, 2-methoxyacetophenone minor product and 4-methoxyacetophenone is a major product. Okay, after that nitration reactions, in the presence of sulfuric acid HNO3, it produce nitrophile like NO2 plus. Okay, this NO2 plus go and attack this ortho as well as the para positions. We can get 2-nitroanisole and 4-nitroanisole major product. Okay, so students, this is your electrophilic substitution reactions, very easy. Friedel-Crafts-நாலே வந்து ரெண்டு ரியாக்ஷன் நடக்கும், அல்கலேஷனும் நடக்கும், அசைலேஷனும் நடக்கும் in the presence of Lewis acid like AlCl3 or FeBr3. ஓகே, ஸோ இந்த எலக்ட்ரோஃபைல் வந்து இந்த ஆர்த்தோ அல்லது பாரா பொசிஷனில் போய் என்ன செய்யும், அட்டாக் பண்ணும். நைட்ரேஷனும் NO2 ப்ளஸ் வந்து ஆர்த்தோ. இதே இது H2SO4னா SO3 HSO3 ப்ளஸ் அது ஆர்த்தோ அல்லது para position. Okay, so these are all electrophilic substitution reactions. Okay.